Hi and welcome to this look at a rather challenging KP question, so let's get into it. The reason it's challenging is because it gives you relatively little information. So let's see what we can do with what we're given. So to help us visualize what's going on, firstly let's put the equation down, and usually we'd use what's called the ICE method, ICE being number of moles at initial, number of moles at change, and number of moles at equilibrium, hence the ICE acronym. But the problem is we don't have actually any moles that are quoted, either at the end or at the beginning, so we have to come at this in a slightly different way. So we do have the total pressure and how much of this pressure might be due to ammonia. So it tells us that 15% of the ammonia 15% of the mixture is ammonia at equilibrium. So if we take the total pressure as 10,000 kilopascals, like you can see in the question, up here, 15% of that is 1,500 kilopascals. So that must mean that that's the partial pressure of ammonia. So the whole point of a KP question is to arrive at the partial pressures for each of the components of your mixture. So we can bypass the need to do the ICE method because essentially we can go straight to working out the partial pressure. So if 15% has ended up as ammonia, that must mean that 85% of the original reactants actually remain. So that's your total partial pressure of nitrogen and hydrogen combined will be 8,500 kilopascals. So obviously 8,500 plus 1,500 adds up to 10,000. So we've got the right proportions so far. Now it says the 1-to-3 mixture of nitrogen and hydrogen at the start. That suggests 0.25 to 0.75 in terms of proportions. So for the nitrogen, you take the 8,500 that it forms part of, and you multiply that by 0.25 or a quarter, and that gives you 2,125. You do the same with the hydrogen, but this time using 0.75, and you get 6,375. So double checking that those add up to 8,500, which is the amount of the total pressure that nitrogen and hydrogen are responsible for. They do add up to 8,500. So these partial pressures must be correct. So we're sort of fact checking what we're doing as we go. So let's clear a bit of space. If we write a KP expression and put the numbers in, we get 4.09 times 10 to the power of minus 9, 3 sig figs. And the units, which is kilopascals to the minus 2, are derived from applying kilopascals to each of the partial pressure terms. So 2 partial pressure terms on the top, 4 partial pressure terms on the bottom. So cancelling through, that gives us kilopascals to the power of minus 2. Okay, thanks for listening. Until next time, see you soon.